to who.print//false transspilling S6. Not all web browsers support S6, and even those that do don't support everything. The only way to be sure that your S6 code will work is to convert it to S5 code before running it in the browser. This process is called transpilling. One of the most popular tools for transpilling is Babel. In the past, the only way to use the latest JavaScript features was to wait weeks, months, or even years until browsers supported them. Now, transpilling has made it possible to use the latest features of JavaScript right away. The transpilling step makes JavaScript similar to other languages. Transpilling is not compiling. Our code isn't compiled to binary. Instead, it's transpiled into syntax that can be interpreted by a wider range of browsers. Also, JavaScript now has source code, meaning that there will be some files that belong to your project that don't run in the browser. Example 2-4 shows some S6 code. We have an arrow function, already covered, mixed with some default arguments for X and Y. Example 2-4. S6 code before Babel transpilling. const @= x = 5, y = 10 = console.log. After we run the transpiler on this code, here is what the output will look like. Use strict var add = function add var x = arguments.length 5 arguments 0 var y = arguments.length 10 arguments 1 return console.logs.y. The transpiler added a use strict declaration to run in strict mode. Variables x and y are defaulted using the arguments array, a technique you may be familiar with. The resulting JavaScript is more widely supported. You can transpile JavaScript directly in the browser using the inline Babel transpiler. You just include the browser.js file, and any scripts with type = text/Babel will be converted even though Babel 6 is the current version of Babel. Only the CDN for Babel 5 will work. src = https://cdnjs.cloudflare.com/ajax/babelcore/5.8.23/browser.js. src = script.js type = text/Babel. Transpilling in the browser. This approach means that the browser does the transpilling at run time. Is not a good idea for production because it will slow your application down a lot. In Chapter 5, we'll go over how to do this in production. Now, the CDN link will allow us to discover and use S6 features. You may be thinking to yourself, great. ENS6 is supported by all browsers, we won't have to use Babel anymore. However, by the time this happens, we will want to use features of the next version of the spec. Unless a tectonic shift occurs, we'll likely be using Babel in the foreseeable future. S6 objects and arrays. S6 gives us new ways for working with objects and arrays and for scoping the variables within these datasets. These features include destructuring, object literal enhancement, and the spread operator. Destructuring assignment. The destructuring assignment allows you to locally scope fields within an object and to declare which values will be used. Consider this sandwich object. It has 4 keys, but we only want to use the values of 2. We can scope bread and meat to be used locally. Var sandwich equals bread Dutch crunch, meat tuna, cheese Swiss, toppings lettuce, tomato, mustard. Var bread, meat equals sandwich. Console.log bread, meat // Dutch crunch tuna. The code pulls bread and meat out of the object and creates local variables for them. Also, the bread and meat variables can be changed. Var bread, meat equals sandwich. Bread equals garlic. Meat equals turkey. Console.log bread // garlic console.log meat / turkey. Console.log sandwich.bread sandwich.meat / Dutch crunch tuna. We can also destructure incoming function arguments. Consider this function that would log a person's name as a lord. Var lordify equals regular person equals console.log regular person.first name of Canterbury. Var regular person equals first name Bill, last name Wilson. Lordify regular person / Bill of Canterbury. Instead of using dot notation syntax to dig into objects, we can destructure the values that we need out of regular person. Var lordify equals first name equals console.log first name of Canterbury. Lordify regular person / Bill of Canterbury. Destructuring is also more declarative, meaning that our code is more descriptive about what we are trying to accomplish. By destructuring first name, we declare that we will only use the first name variable. We'll cover more on declarative programming in the next chapter. Values can also be destructured from arrays. Imagine that we wanted to assign the first value of an array to a variable name. Var first resort equals Kirkwood, score, Alpine. Console.log first resort / Kirkwood. We can also pass over unnecessary values with list matching using commas. List matching occurs when commas take the place of elements that should be skipped. With the same array, we can access the last value by replacing the first two values with commas. Var third resort equals Kirkwood, score, Alpine. Console.log third resort / Alpine. Later in this section, we'll take this example a step further by combining array destructuring and the spread operator. Object literal enhancement. Object literal enhancement is the opposite of destructuring. It is the process of restructuring or putting back together. With object literal enhancement, we can grab variables from the global scope and turn them into an object. Var name equals Talik. Var elevation equals 9738. Var fun height equals name elevation. Console.log fun height / name Talik, elevation 9738. Name and elevation are now keys of the fun height object. We can also create object methods with object literal enhancement or restructuring. Var name equals Talik. Var elevation equals 9738. Var print equals function. Console.log mount this dot name is this dot elevation feet tall. Var fun height equals name elevation print. Fun height.print / mount Talik is 9738 feet tall. Notice we use this to access the object keys. When defining object methods, it is no longer necessary to use the function keyword. Example 2 to 5. Example 2 to 5. Old versus new object syntax. / old var skill equals. Name, sound, outer yell function. Var yell equals this.sound.uppercase. Console.log yell. Speed function. This.speed equals miles per hour. Console.log speed, miles per hour. / new const skill equals. Name, sound, outer yell. Let yell equals this.sound.uppercase. Console.log yell. Speed. This.speed equals miles per hour. Console.log speed, miles per hour. Object literal enhancement allows us to pull global variables into objects and reduces typing by making the function keyword unnecessary. The spread operator is 3 dots that performs several different tasks. First, the spread operator allows us to combine the contents of arrays. For example, if we had 2 arrays, we could make a third array that combines the 2 arrays into one. Var peaks equals Talek, Ralston, Rose. Var canyons equals Ward, Blackwood. Var Tahoe equals peaks, canyons. Console.log Tahoe.join / Talek, Ralston, Rose, Ward, Blackwood. All of the items from peaks and canyons are pushed into a new array called Tahoe. Let's take a look at how the spread operator can help us deal with a problem. Using the peaks array from the previous sample, let's imagine that we wanted to grab the last item from the array rather than the first. We could use the array.reverse method to reverse the array in combination with array destructuring. Var peaks equals Talek, Ralston, Rose. Var last equals peaks.reverse. Console.log last / Rose. Console.log peaks.join / Rose, Ralston, Talek. See what happened. The reverse function has actually altered or mutated the array. In a world with the spread operator, we don't have to mutate the original array, we can create a copy of the array and then reverse it. Var peaks equals Talek, Ralston, Rose. Var last equals peaks.reverse. Console.log last / Rose. Console.log peaks.join / Talek, Ralston, Rose. Since we used the spread operator to copy the array, the peaks array is still intact and can be used later in its original form. The spread operator can also be used to get some, or the rest, of the items in the array. Var lakes equals Donna, Marlette, fallen leaf, cascade. Var first, rest equals lakes. Console.log rest.join / Marlette, fallen leaf, cascade. We can also use the spread operator to collect function arguments as an array. Here, we build a function that takes in n number of arguments using the spread operator, and then uses those arguments to print some console messages. 2 rest / spread properties. Function directions, args. Var start, remaining equals args. Var finish, stops equals remaining.reverse. Console.log drive through args.length towns. Console.log start in start. Console.log destination is finish. Console.log stopping stops.length times in between. Directions. Truckee, Tahoe City, Sunnyside, Homewood, Tahoma. The directions function takes in the arguments using the spread operator. The first argument is assigned to the start variable. The last argument is assigned to a finish variable using array.reverse. We then use the length of the arguments array to display how many towns we're going through. The number of stops is the length of the arguments array minus the finish stop. This provides incredible flexibility because we could use the directions function to handle any number of stops. The spread operator can also be used for objects. Using the spread operator with objects is similar to using it with arrays. In this example, we'll use it the same way we combine two arrays into a third array, but instead of arrays, we'll use objects. Var morning equals breakfast oatmeal, lunch peanut butter and jelly. Var dinner equals mac and cheese. Var backpacking meals equals morning, dinner. Console.log backpacking meals / breakfast oatmeal, lunch peanut butter and jelly, dinner mac and cheese. Promises give us a way to make sense out of async